Let's start. So now we are going to study data communications and computer networks, DCN CSC 339 course code. In the last class, if you do remember, so we have discussed chapter number 1. We were discussing chapter number 1, and more particularly we had discussed network H, host access network technologies, and different types of access networks, as well as we have also discussed physical media. So in today's class we are going to discuss and we are going to continue chapter number 1 again, and we are going to discuss network core. And in the network core we are going to discuss two types of approaches: circuit switching and packet switching technologies in detail through some examples. So as we know that a computer network or the structure of internet, so internet can be divided into two parts: network edge or host. That is, network edge is that part of the internet which attach the host, the end system, to the first router. This is called network edge. This is called network edge, or it is also called access network. So we have discussed different types of technologies that are used for access network. Now the second part of the internet is network core. Network core means the interconnection of routers. When these routers are interconnected, so this part of the internet, it is called network core. Network core is the interconnected routers. So the network that interconnects the routers among themselves, this part is called network core. Now there are two approaches. When the first router of the internet, it receives the data. For example, this is the laptop, and this laptop wants to send data to this desktop. So the network edge, it will sends the data to the first router. And now this router, it has two functionality. The first functionality is to compute the best path in the core network from this router to destination router. The destination router is the router where the destination host is attached. So when this is computed, then the data is moved or traversed from source router to destination router through the core network. So when the data is moved from source router to destination router through the core network, through the network core, there are two approaches. One is called circuit switching and one is called packet switching. So again I would like to emphasize that the internet structure, it consists of two parts. One is called network edge. The network edge is the part of internet where the host, where the end system, they are connected to the first router. This is the network edge, access network. This is the network edge part. And when the host sends the data, so it is received to the first router. Then the first router, it moves the data through the network core toward the destination router. So moving the data from the source router to the destination router through the network core, there are two approaches. One approach is called circuit switching technology and another approach is called packet switching technology. So I think it is now clear, and now we are going to discuss what is circuit switching and what is packet switching, and we will discuss them through examples. Circuit switching. Circuit switching, it is basically In circuit switching, end-to-end resources are allocated. They are reserved. And how they are reserved? By call between the source and destination node. Okay, so let's discuss it. What does it mean? For example, this is a source, host B. It wants to send data to A. This is the destination. Or suppose this is the router. A is the router, this red one. A is the host, it is the source node, and it wants to send data to destination B, the red one. Okay, and suppose in this diagram each link is 2 MB. The bandwidth of each link is 2 MB. This link is 2 MB, this link is 2 MB, this, each and every link is 2 MB. Okay, and suppose A wants to communicate with B, and this communication, they required that the minimum bandwidth, the required bandwidth should be 1.5 MB. Okay, so that is A wants to communicate with B and their data rate should be 1.5 MB. It is their requirement. Okay, so how they can talk with each other using circuit switching technology. Okay, so the first one is the call setup. First of all, before communicating, A should establish a circuit to B. That is, A should allocate resources from A to B on the path. That is, A should reserve the resources toward B, from A to B. And how much? It is 1.5 MB bandwidth. Okay, so how it is done? Let's see it. So first of all, A will send a request, this red one. A will send the request to router. This router, it will, suppose there is no other traffic. There is no other traffic. So this router say that okay, this link is the free. So it reserve 1.5 MB on this link. This link is total how much? It is 2 MB. So it will reserve 1.5 MB here. Okay. Similarly, this router, it will forward the request and it will also reserve 1.5 MB here, and so on and so on. So you can see that the path or the resources are reserved from A toward, and this path toward B. So when the resources on this path are reserved, so it is reserved from them for communication from A to B. This resources cannot be used by anyone else. Okay, so after this the resources are reserved, then the data is transmitted from A to B. Okay, so on this link 1.5 MB is reserved for who? For communication from A to B. So this link is total 2 MB, so it means that 1.5 MB is reserved for A to B communication, so 0.5 MB is free available. Similarly here, this link is how much? It is 2 MB and 1.5 MB is reserved for A to B communication, so 0.5 MB is remaining. Okay. Now suppose C wants to communicate with D. C wants to communicate with D. So, and they also need 1.5 MB data rate. So before they communicate, they also should reserve the resources. So they will do a call setup. Call setup means they have to first have to allocate resources, to reserve the resources from source to destination by call. Okay, so how it is, let's see it. For example, this is the C node, yellow one, and this is the D node. Okay, so the host C, it sends the call or request to router, so it is reserved. The router, you can see that this link it's 2 MB, but 1.5 MB is reserved for A to B communication. So 0.5 MB is remaining, and C to D wants 1.5 MB. So this link cannot be used because 0.5 MB is empty. So this router will use this link because this link is fully available. It is free. So here it is reserved. This again, this router it reserved here. Okay. So and this router reserved the path here. Now this router have, because the destination is here D, so it passed through this link. And you can see this at this link is how much it is 2 MB. Every link is 2 MB. And on this link from A to B communication 1.5 MB is reserved for A to B communication. So 0.5 MB is remaining. And for C to D it requires 1.5 MB. So 1.5 MB is more and 0.5 MB is less. So it means that this link cannot accommodate C to D communication. So the call setup for C to D, it will be not set up. It will be rejected because it will be rejected. That is, the network is busy. The network is not available. Although you can see that this A to B, this link is reserved for A to B 1.5 MB, and A to B there is no communication. A and B are not exchanging the data, so it is free, but it cannot be used. Why? Because it is reserved for A to B communication. So the circuit segment is idle if not used by call. So if although this link is reserved for A to B, but the AB are not talking, they are not sending the data, but if they are, so it will be idle. It cannot be, but it is reserved. Reserved means that it cannot be allocated to anyone else. Okay, so this is the circuit switching technology. So you can see that in circuit switching technology, the resources are dedicated and there is no sharing of resources. This link is reserved for A to B communication, and if C to D wants to talk, to use this, they cannot use because it is already reserved for A to B communication. So the circuit switching, it has guaranteed delivery. Why? Because this path is reserved for A to B communication. So whenever A sends 1 bit, so it will be moved directly on this path, and there will be no waiting. It will not wait. It will directly move from A to B on this path. So, and there is no packet loss because it is already reserved. It is like that, for example, if Prime Minister of Pakistan, he is coming from Lahore to Islamabad on the GT road, and the GT road is reserved. It is reserved. So there is no other traffic. So when Imran Khan come on junction, so it will be already available. So it will directly move. It will not wait. So you can see that in the circuit switching technology, the performance is guaranteed. What does it mean? That there is no packet loss. There is no delay. Only delay is the propagation delay. Propagation delay means that it has to move with certain speed. This is the delay involved. Okay. If the circuit segment is idle, then it cannot be used. There now, for example, this circuit is established from A to B, and A and B are not sending data. They are not sending data. If they are not sending data, then this circuit, this link is idle. It cannot. It is wastage. So circuit switching technique is where used. It is normally used in telephone network. Why? Because in the telephone network, if someone wants to talk, it is continuous in nature. For example, when you make a call, so you are talking continuously. So if one is talking continuously, then for continuous data, the circuit switching technology is used. It is preferred. Okay. So the circuit switching, it is used for telephone network which has continuous data rate. Continuous data rate means when you make a call, so you are talking continuously. Okay, so that's why it is used for circuit switching, because the resources are reserved, because it is assumed that when the resources are reserved, they will be used for communication from A to B. Okay. So how the link is shared, you can see that how the link is shared, how this physical link is shared between two communication. So for this purpose we have different technologies. One is called FDM is called frequency division multiplexing. That is, the link is divided into frequency, by the link is shared by frequency. Okay, for example, here there are 4 users, so if there are 4 users, then the link is divided into frequency by 4, like this way. Okay, and another technique is called TDM, time division multiplex. The link is used time wise. For example, for the first 5 seconds it is used by 1 user, for the next 5 seconds it is used by second user, for the third 5 seconds it is used by third user, for the fourth 5 seconds it is used by fourth user, and again when all 4 users are served, then for the fifth 5 seconds it is used by the first user again. Okay, so it is used like this way. For example, the first user it used for 5 seconds, the second user, the third, and the fourth. Again when all 4 users are finished, then the first user again used for 5 seconds the link. Okay, we will discuss it in the chapter number 6 in more detail. Okay, so you can see that in circuit switching technology, how it works. In circuit switching technology, first of all, when A wants to communicate with B, so first they have to reserve resources. So how they reserve resources? They send a call setup request. When it is sent from A to B, this is the time when the call is initiated. When the call is initiated at this time, for example, at t is equal to 0. Okay, so it takes some time. Then there is some waiting time. Why waiting time? Because this router, it has to think about that which link can be used, which link is freely available, which link is freely available. So for this it requires some time, so that's why it waits for some time. After this, when for example this link says that okay, this link can be used, so then it sends the request on the next link, and so on. Okay, so once the call setup is established, the circuit is established from A to B. After this, the data is moved. When the circuit is established, when one bit is transmitted, it will directly move from A to B. There will be no waiting. There will be no waiting time. Why? There is no delay. Why? The only delay is the moving speed. That how much with which speed the data is moving. Okay, and there is no data loss because this link is already reserved for A to B, so it will be used directly. Okay. So you can see that this is the behavior of circuit switching technology. So there is time required, significant time is required to establish the call. Establish the call means to allocate, to reserve the resources, from source to destination. And after the resources are reserved, then when the data is sent, it will directly move to the destination. This is like, for example, when Prime Minister of Pakistan, it moves from Lahore to Islamabad. So on the GT road, then the whole GT road is reserved for Prime Minister. So that it doesn't wait. So the only time that it takes, it is the moving speed. Okay. So this is the behavior of circuit switching technology. Okay, so I think you will have understand. I think it is clear. Okay. So now we are going to discuss another important topic, and that is called packet switching technology. Okay. So again, I would like to emphasize that in packet switching technology, okay, suppose this is the diagram. A wants to send the data to B. Okay, so first A has to divide the data into packets. Okay, and suppose each link is to MB and AB wants to communicate. Okay, so how it works? So in packet switching there is no call setup. Okay, that is, in this diagram, suppose A wants to send data. So A will divide the data into packets. In each packet it will have the source and destination address. And there is no call setup. So A will directly send the packet to router. This router, it will, when it receives the data, so it stores the data. It stores the data until the whole packet is arrived. When the whole packet is arrived, then this router examines the packet. That the packet is coming from where? The packet is coming from A. And the packet is moving to where? The packet is moving toward B. So the router examines, check the source and destination address of the packet. And based on the source and destination address, a router has forwarding table. A routing has a table information that for destination B, which path is the best one. For example, this path is the best one. So it sends the data on this link. When the data is sent, again this router will receive the whole packet. It will store the whole packet. It will not forward the packet until the whole packet is received. When the packet is received, then it also examines the packet source and destination address. That the packet is coming from where? The packet is moving to where? So here the packet is coming from A and it is moving toward B. So it has some information that which path is best. Suppose this path is best toward B. So it forward it. So you can see that each packet is forwarded by each router in store and forward fashion. Store and forward means that when this packet is received, when this bit is received, it will store it until the whole packet is received. I will like to show it through an example. Suppose here. Okay, here you can see it. In circuit switching, when as soon as the data is received, it is directly forwarded. But here in the packet switching, for example, when this data is received here, so this data will be stored. It will be stored until the whole packet is received. When the whole packet is received, so it is stored. When the whole packet is received, again you can see here is some time, gap, waiting time. This time is used to examine this whole message, that what is its source address, what is its destination, and which will be the best path. So after this the message is forwarded. So you can see the message start from here to here. So when this part of the message is received, it will not be forwarded, it will be stored until the whole packet is received. Until the whole packet is received. But here in the circuit switching, when as soon as the data is received, it is directly forwarded. Why? Because here the path is reserved for communication from A to B. But here the path is not reserved. The path is not reserved. So when the whole packet is received, so each packet, it has the information of source address and destination address. So after receiving the whole packet, the router examines the source and destination address, then it forwards the message. So this time is taken. This is the waiting time. Okay. So you can see that. So this is suppose A and B is transmitting the data. A is transmitting data to B. Okay, and A is transmitting data with the 1.5 MB data rate. Okay. Now suppose that C wants to send data, and C also send the data rate at 1.5 MB. So you can see that this data, because in packet switching there is no circuit, there is no call, there is no resources allocation. So therefore it will the C will divide the data into packets, and each packet will have destination and source address, and then C transmit the data to router. Now when this router receives the data, so it forwards on this link toward this router. Okay, suppose this data router receives the data. So this router receives the data from A, and it also receives the data from C. From A, this blue color, and this yellow color is the data from C. So you can see that A is sending data at 1.5 MB, and C is also sending data at 1.5 MB. So it means that here 3 MB data is arriving. 3 MB data is arriving, and the link is 2 MB. This link is 2 MB. So the data is 3 MB, but the link is 2 MB. So 2 MB data can be transmitted, 1 MB data should be stored. Okay, so when two packets are received, so the first packet will be transmitted and the second packet has to wait. Okay, so where it has to wait? So each router, it has a buffer. It has memory. It has memory space. It has buffer. It is stored in buffer. Okay, if some more packets come and the buffer, there are packets in the buffer, so the arriving packet has to wait. They will be inserted in the queue, in line. They will wait until their turns come, then they will be transmitted. Okay, so this is called store and forward. Okay, and sharing resources, here you can see that A and C, they both can send data at same time, and they both can share the link. Okay, in packet switching, but in circuit switching, as we have explained, they can A and C, they cannot send data at same time. You can see that here A and C, here it cannot send the data. Why? Because it is reserved for A. So and 0.5 MB is remaining, so and C wants 1.5 MB data, so it cannot use. Okay, so in the previous example, so in this example, you can see that in circuit switching, when A was talking and C cannot talk. Okay, C cannot talk. Okay, so now we are going to so in packet switching there is resource sharing. Okay, so you can see that A and C, they can both send the data in packet switching technique. So they are sharing resources, they are sharing this link. It is now guaranteed delivery. What does it mean? As I have said that two packets has arrived, and each packet is 1.5 MB, and this link is 2 MB. So it can send 2 MB data, 1 MB data has to be stored. That is, one packet will be transmitted first and the other packet will be stored in the queue. When the first packet is transmitted, then the second packet from the queue will be transmitted. Okay, so where this packet is stored? This packet is stored, the second packet is stored in the queue, in the router queue, in the router buffer. It may happen that the router buffer is full. There are many packets waiting in the buffer, and another packet comes. For example, the packet is coming from A. So when the packet arrives and the buffer is full at this router, so what will happen? The arriving packet will be discarded. It will be dropped. It will be dropped. So when it is dropped, it means that the packet is lost. The packet is lost. So there is no guaranteed delivery. In circuit switching, there is guaranteed delivery because the resources are reserved. So when the resources are reserved, the packet will directly move. Okay. So the packet switching is like GT road. Like a GT road. When you comes on a junction, you come on a junction, and suppose there is a choke, and their choke, the there are many cars waiting, okay, and there is some accident, okay, so you have to wait in the queue, and it may happen that you will not find the time to move in a 1 day or in a 2 day, okay, maybe the road is blocked for, okay. So if the segment is idle, it can be shared by other. So for example, if A is not sending data, then this link will be used by C to send the data, okay. So the packet switching technology, it uses store and forward. So I have explained it through example. So it is used where it is used for bursty data. Circuit switching is used for continuous data. Circuit switching is used for continuous data. You can see that circuit switching, it is used for continuous data, like telephone conversation, like mobile phone conversation. So it is used, they are using circuit switching. And telephone and packet switching, it is used for bursty data, okay. So what is mean by bursty data? That sometimes the user sends the data and sometimes the user doesn't send the data. Sometimes the user sends a large amount of data, sometimes the user sends less amount of data. So the internet, it is using packet switching technology, because in the internet sometimes the user is sending data, sometimes it is not sending the data, okay. Okay, now we would like to explain packet switching through another example, store and forward, how it works, okay. So in packet switching, please give proper attention to this example because it is needed, okay. So we will discuss it in the next video.